Yeah, so good morning, everyone, or afternoon, depending on where you are. So following off the back of the presentations that we've just seen, I'll be touching on some alternative methods that really complement the video-based analytics that Jason was talking about. And I'll provide a bit of perspective about coastal monitoring for beach safety. So just to kind of tease out where I come from in this space, being a coastal engineer, I've been involved in using cameras to monitor how beaches change due to erosion and storm events. And in recent years, well, not in recent years, since the research world really pioneered the technique of using cameras to monitor shorelines 20 years ago, the organisation, the Water Research Lab that I work from, has been applying that in an operational sense for the last 20 years, mainly on the Gold Coast for the city of Gold Coast. So in recent years, with machine learning really coming to the fore, we've been really jumping on board with new techniques to look into things like people counting, which is what I'll present about today. So just a bit of an overview of my presentation. I'll go, first of all, I'll kind of touch on a low-cost coastal monitoring camera system that we've developed based on our experience managing the really high-end systems. We've brought a lot of learnings to a low-cost system that may be useful in lots of situations. I'll go through the people counting method that we've applied using those cameras and on other cameras, and then I'll touch on some trends on beach usage from around Australia in the past 12 months, and then I'll touch on some operational examples like Jason and other presenters have spoken about. It's really important to deliver this information in a way that is useful to the people who need to use it. So there's an example of McMaster's Beach on the New South Wales Central Coast, just north of Sydney. It's the place I grew up, so I've kind of invested and I've had a bit of a pet project pioneering our system on that location. So in terms of simplified coastal monitoring, we've developed a really low-cost camera system that's based on trail cams or hunting cameras. So these systems are off the shelf and they're really easy to use, and they're solar powered, and they have a SIM card in them that allow them to transmit data. One thing you need to note is these systems are separate from the closed circuit CCTV video systems that Jason was talking about. These ones are really based on imagery rather than videos. They do allow you to transmit a 10-second video, but it's really, that's more for looking at animals in a video. Say you've got it out in a paddock and you want to look for deer. They're not designed for having a continuous stream of video. And because of that fact, they're a lot cheaper and they have much less power requirements. So there's an example of one installed up on the Gold Coast. They're just a neat little box. We tend to hide them in plain sight, putting them in that nondescript box. And they're completely solar powered, don't need power or any form of internet connection other than the SIM card. And one thing that I've known installing camera systems to monitor the beach is it can be really cumbersome to sort out your power and your comms. Normally, when you want to monitor the beach, you're out, you want to install your camera really close to the action, and there's often no power on a lot of these lifeguard towers or on the beach, and there's no hardwired internet connection. And that makes it really difficult if you're trying to install video systems. So I really see that these camera-based systems have their own place in situations where you may not already have an existing CCTV network, or you perhaps don't have the access to the funding required to set a lot of these up. So they see them as a complement to using video-based people counting. And really the whole reason we're here is for beach safety, but also I think it's really important to apply these kinds of techniques to understand the economy of the coast. How many people are visiting different locations? If you're a council that manage multiple beaches, where should you prioritize your expenditure? And a lot of the time you don't have the best information at hand to make those kind of decisions. So camera or video-based counting really pulls out any of the rubberiness of people counting statistics that might already be out there existing. So let's talk about people counting. How does it work and what can it give you? So people counting has really exploded in recent years, and that's mainly due to a lot of research efforts into the field of autonomous driving. So there's researchers all around the globe that are dedicating hours and hours of their time to try and develop cars that can detect people so that you don't need to steer your own car. And in that environment, it's critical that you never miss detecting a person, because the consequences are you run that person over. I'd like to feel that in the instance of counting people on the beach, it's less high consequences. So that means you can relax some of your tolerances about how accurate the technology needs to be. The other thing is, because of all of that hard work that other researchers are doing, it's now becoming more accessible to access people counting models that are really good at what they're doing, because people have spent a lot of time drawing boxes around people to train a computer what a person looks like. So here's an example of a beach taken from one of our trail cams on the Central Coast. Once you feed that into an algorithm to count people, it draws a box around them and it gives you a confidence that that's a person. So in this instance, you can see that the confidence range is from 80% to 100% that it's a person, but you might also note that it can't really detect some of these people well up the beach that are only a few pixels high. So that'll come into play a bit later about where you're counting and how far your range is. So one thing that was touched on earlier this morning is, how do you go from people counting in a frame, in an image, to the number of people that are visiting a location? So the gold standard would be to have a video system that continuously records the beach, and you would perhaps have a tripwire maybe, and as people walked past a virtual tripwire, you would count the number of people. That would be quite it requires a lot of computational resources. You'd have to have a computer running 24/7 to do that. So we've got to make some concessions. So with the camera system that I've presented, we're limited. It's transmitting one picture every 15 minutes. So we're looking at how many people are on the beach in 15-minute intervals. And so the question is, how do you go from that to how many people visited the beach throughout the day? So there's not heaps of research out there, but there was some research done by Dave Anning a decade ago, who surveyed beach users in Sydney and said, how long do you normally stay at the beach? Obviously, there's a lot of variance, but the average visit duration was between 1 to 2 hours. As I was mentioned earlier in the panelists, different beaches would have different fingerprints about whether people stay for longer or less, whether they're walking their dog or doing other things. So you've got to take that into account. But for the purposes of counting people using imagery every 15 minutes, you've got to make some assumptions. So we make the assumptions about how long people are going to be on the beach. And then over the period of the day, you can look at how many people you estimate visited the site over time. So what does it give you? Here's an example of close to 12 months of people counting on the Central Coast. What you can see is, as we get into the summer months, as Jason said, you get more people on the beach. This was actually before COVID, so there's no COVID impact on this particular beach count. But as we come into the Christmas period, you're getting more and more people on the beach. The other thing our camera sister can do is monitor the shorelines, which is our bread and butter. That's where we came from. So if you're trying to look at funding for these kinds of systems, if you can engage with councils that are perhaps interested in coastal erosion, you might find a win-win in able to get some funding for these kinds of systems. So I touched on detection accuracy. One of the biggest ones is, how big in pixels are the people? If they're a long way down the beach, the computer isn't really trained to detect people when they're only a few pixels high. And also it gets a bit confusing to a computer and to a human what a person looks like when they're 3 pixels high. So there are limitations, and that's based on the resolution of the camera and the zoom. The other thing is, what is your model trained to detect? So there's a lot of models out there that already exist that are good at counting people when they're walking on the street. You do need to tweak these kinds of models to pick up people that are sitting or sunbaking on the beach. The models that I'm using can count people on the dry beach, but in terms of people in the water, it gets a lot more difficult. There are some systems out there, particularly the surf cam company Surfline. They have a very good, robust algorithm at counting surfers. So if that's something that's really critical, then I'd suggest you have a chat to Surfline. For their purposes of, for beach user tracking, we're developing ours to count people in the water, but it's a lot more difficult because people are generally obscured by the waves and the like, but that's in progress. The other thing that affects detection accuracy is sun glare, water droplets, is it raining, and are people partially obscured or clumped together in groups? But what type of accuracy do I need when you're looking at trends on the beach? Here's an example of a plot of predicted count from a model versus actual count. And you can see there's deviation, and that's going to happen with any computer model. But in terms of what accuracy do you need, I personally feel like when we're doing this kind of thing, we just need to get the trends of people at the beach. Are you picking up the peak in the day? Are you picking up troughs when there's not a lot of people around, rather than having 100% accuracy? So the other thing to note that's been touched on is it's consistent. If you have lifeguard A versus lifeguard B counting the beach, they may have broadly different methods when they're counting the beach, whereas the computer, if it gets it wrong, it's consistently wrong the same way in the same circumstances, so that you have consistency. The other thing is I don't believe you need 100% accuracy in this field. The other thing is pixel size. It's really challenging if you've got an image like this up on the Gold Coast. This is one of our coastal monitoring cameras on the top of a high-rise building. It's really hard to count people in these kinds of things. There are some promising developments with machine learning in crowd counting like this. It is getting mature, but I don't feel like it's really quite there yet when you've got images like this. The traditional method is to do a thing called binary classification, and Dr. Mitch Harley at the Water Research Lab helped us develop a bit of a technique to count people in these kinds of images. And what you do is you kind of split an image up into black versus non-black kind of pixels, and you cluster them together. And then depending on what you think the size of a person should be, their pixel footprint, you can pull it together and look at people counts. This obviously isn't reliable as the machine learning based system, but in the absence of other techniques, this is one that may be a viable option. So let's get into some results. I think this is the more interesting part of the people counting. So I'm going to touch on 3 different sites spread throughout the east coast of Australia and look at some people counting trends. So let's first start with Ettalong, just north of Sydney on the central coast. So here's our camera system on a lifeguard tower, and that's the view of it, counting people. If we have a look at what time of the day are people most likely to visit the beach, at this particular site, you have not so many people bright and early at 7 a.m. And then it has a bit of the fingerprint, I'm going to call it, of this beach looks a bit like this. So we'll keep that in mind as we compare it to some other sites, but you kind of flatline once you hit 10 o'clock, you have consistent numbers on the beach. If you have a look at what day of the week are people most likely visiting the beach, as we saw in Jason's plot, Sunday is the busiest day in most locations, and particularly at this site, with 24% of the visits occurring on a Sunday. In terms of seasonality, if we look at the month of the year, you could see seasonal trends. Not a lot of people are getting to the beach in the winter months, whereas it ramps up towards Christmas and summer months. All right, let's jump to Blacksmith Beach and Redhead, just south of Newcastle. So for the Smart Beaches project with Tony, we were looking at doing people counts at Redhead Beach and Blacksmith Beach. So keep in mind, these are at 2 ends of the same embayment, so to speak, but they have very different beach visitation trends. So in this instance, instead of using one of the trail cameras, there's alternative camera systems out there that remove the need for power and comms. And one of the companies out there in Australia is called Spectre, and they have a really good system that is very easy to install on the beach. And the benefits of this system is that they do provide a live video feed of 2 frames per second, and that can unlock some more accurate people counts if that's what you need. They're solar powered and transmit images via 4G, and they're at quite a reasonable price point at around 5,000 Australian dollars. So here's the feed from 2 of those cameras at either ends of the same beach, so to speak. You can see the busiest day was in August 2020. This was, I believe, in the school holidays after we had the second lockdown in Australia lifted, and people were kind of starting to get back into the swing of things and heading to the beach. If we have a look at the plots between April and September, you can see the plots of people at these 2 beaches. You can see the busiest day was just there. What you can also note is the scale. So Redhead Beach at the northern end of that embayment gets a lot more people compared to Blacksmith Beach. So you can see the scale on the left here is 2,000 versus 800 people. So you get a lot more people visiting Redhead. The other thing you can do is you can look at what the busiest day of the week is. Once again, it's Sunday and Saturday at both locations, but you can see at Blacksmith, Friday is a bit of a contender. And speaking to the lifeguard, a lot of people head to this beach after school on a Friday. Last thing you can do is you can look at the month of the year and you can see similar seasonal trends. All right, so let's jump well further north to the Gold Coast, to Burleigh Beach. So we installed a camera on one of the lifeguard towers as a trial for the City of Gold Coast, and we did some people counting towards the end of last year. Here's the results of the plot here. You can see there was a very busy day just at the start of December 2020, and then a storm hit, which kept a lot of people away from the beach as the cyclone smashed the beach, and it wasn't particularly nice. Coming into the Christmas period, we had a lot more people down at the beach. And then we move forward through to the end of January. So looking at those results, we can compare the time of the day and the day of the week. We could see that Burleigh Beach has a different footprint to Ettalong. If we looked at Ettalong, it had this kind of flat lining, whereas at Burleigh, you get a lot of people that are visiting at 7 a.m., maybe the boot camp people, and then it kind of peaks at midday and trails off towards the end of the day. Sunday is also the busiest day, as we've seen at a lot of these sites. Total beach users between December and January was about 8,000 people, based on our assumption of people staying for 1 hour. Other uses, coastal monitoring. As I mentioned, you can use these cameras to track shoreline change. This is a beach just north of Sydney called Turrametta, and you can see just how dynamic this beach is. Looking at it throughout a 12-month period, there's rocks that become exposed that weren't exposed in the summer months, and that can really change beach safety. And these kinds of systems provide unprecedented information for research into how our beaches change. Other things that we've been looking at is analysis of rip breaking. So here's this analysis developed by a New Zealander researcher called Tom Shand, who's looking at where a wave's likely to break. And as a result, you can see where the waves are not breaking, green is mean, is where we're likely to see rip current. So this is an alternative method to some of the machine learning based rip detection methods out there. In terms of operational use, this is the last kind of part of my screen. Tying it all together, how do you present the information to people that need it? So here's an example of 9 cameras that are installed on the Central Coast, just north of Sydney. And you can kind of see how these camera systems could assist you in managing a beach. We've got a time lapse here that is updated every night so that you can look at long-term changes to a beach. You can also look at the local tide data or wave data that's measured nearby, water levels and rainfall information. You can also have a look at some shoreline change, as we see here as we jump to Wombrel. You can have a look at how the beach is changing throughout time. And then lastly, if you're looking at a people counting thing, as Jason mentioned, you've got to have a dashboard if you want to deliver this information to people. Here's a bit of a proof of concept for what a people counting dashboard could look like. I'm sure there's many different ways of presenting the information. Do you want to know what's the people on the beach now? Do you give it a scale between 1 to 5? Are you interested in where people are on the beach, which you can kind of put the dots on a map to see where people are likely to be, and hopefully, improve beach safety. So that's kind of it. This final slide here shows you that when you're counting people on the beach, you got to stay on your toes, because sometimes you can see strange things like a horse on the beach. And this is up at Jimmy's Beach near Port Stephens, where when I saw the output of a horse, I think the computer's a bit confused, but upon reviewing the footage, there actually was one. So on that note, thank you for your time, and I'll take any questions.